All right, example 1. Which team will win the race? You have decided to walk in a long distance race. There are 2 teams that you can join. Team A walks at a constant rate of 2.5 miles per hour. Team B walks 4 miles the first hour and then 2 miles per hour after that. Our task is to create a table for each team showing the distances that would be walked for times of 1, 2, 3, 4, 5, and 6 hours. Using your tables, answer the questions that follow. So we're going to make 2 tables here. We've got a team A and a team B. So for each team, we need to find both the time in hours and then the distance in miles. All right, so again, we're finding this for 1, 2, 3, 4, and 5 hours. And for team B, 1, 2, 3, 4, and 5. So if we go back to our problem, it says team A walks at a constant rate of 2.5 miles per hour. So for the first hour, they go 2.5 miles. And then another would be a total of 5, and then 7.5, 10, and 12.5. Team B walked 4 miles the first hour, and then they only walked 2 miles after that. So we're going to add an additional 2 miles to this. So 6, 8, 10, and 12. All right, our next question. For which team is distance proportional to time? So if we're looking at our tables, some key things we need to look for are that they increase at a constant rate. So if we notice on team A, if they were to start at 0, 0, we're going to add this on here, 0, 0. So that would be the very start of the race. They're standing at the starting line. After the first hour, they go to total of 2.5 miles. And then the second hour, they go another 2.5, so a total of 5 miles. So notice how this increases at a constant rate each time, starting at 0, plus 2.5, plus 2.5, plus 2.5. If we look at team B, if they were to start at 0, 0, they would go from 0 to 4, which is a difference of 4, and then from 4 to 6 would be a difference of 2. So see how that is not constant. It was 4, and then they slowed down to 2. So our team where distance is proportional to time would be team A, because they increase their distance by a constant rate. Also, the ratio of distance to time, or we'll say the ratios of distance to time, are equivalent. In other words, if we go 2.5 to 1, we get 2.5. If we go 5 to 2, we get 2.5. If we go back to our table, so 7.5 to 3, we get 2.5. If we go 10 to 4, we get 2.5. And if we go 12.5 to 5, we also get 2.5. Okay. Explain how you know distance for the other team is not proportional to time. So if we're looking at this one, let's consider that start of the race again. So our 0, 0 is our starting line. So that first hour, they went 4. And then that next hour, they went an additional 2 to get 6. So from here to here, it went up 4. And then from here to here, it went up 2. So this difference, this change, makes this not constant. So there is not a constant rate. the ratios are not equivalent. So I'm going to write out the ratios for this little table here. So I have 4:1, which is 4, and then 6:2, which is 3. And all it takes is one example to show that they are not the same for us to say that it is not proportional. All right, at what distance in the race would it be better to be on Team B than Team A? So if we look at these distances, we're looking at who's going to be in the lead. So at what point on Team B do we want to be in the lead? So if we look at this, we'll notice here at 10 miles, they both tie at the same time. So it's better to be on Team B. So like at 1 hour, Team B is leading. At 2 hours, Team B is leading. At 3 hours, they're still barely leading. So any distance less than 10 miles, we would want to be on Team B. So we're going to put any distance less than 10 miles, because they are in the lead up to that point. Okay, our next question. If the members of each team walked for 10 hours, how far would each team member walk on each team? Okay, so we know for Team A, they have that constant rate of 2.5 miles per hour. And if they walk for 10 hours, if we take 2.5 times 10, that would give us a total of 25 miles. So that one's not too hard to figure out. All right, let's talk about Team B. So that first hour they go 4, and then every hour after that, so here, first hour, they go 4 miles. So every hour after that, so that would be 9 hours. So the 9 other hours, they walk 2 miles per hour, which would be a total of 18 miles. So if we take that 18 miles, sorry, got that out of the screen. If we take that 18 miles and combine it with that original 4, we would get a total of 22 miles. Okay. Will there always be a winning team no matter what length the course is? Why or why not? So we need to go back and look at our table. And let's get that table in there. So we're looking at this, will there always be a winner? So we said up until this mark right here, let's maybe mark it in a different color. This part right here, Team B is the winner. And then after this mark here, Team A takes the lead and starts to become the winner. So what if that race was exactly 10 miles? Would we have a winner? Well, since they both take the exact same time, no, it would be a tie. So no, at 10 miles, Team A and Team B tie. Let's see if we have one more question. Oh, yeah, one more question. I think I have an extra paper here. Hold on. Yeah. All right. If the race is 12 miles long, which team should you choose to be on if you wish to win, and why would you choose this team? So if that race is 12 miles long, I notice Team B, it takes them 5 hours. But Team A is at 12.5 miles at 5 hours. So I would want to be on Team A because we're going to finish just a little bit before Team B. So Team A because at 5 hours they have already finished and Team B is just finishing.